About 3 months ago, some kind fellow sent me a message asking if I wanted some scrap that he'd found in his garage. Yes, I said, can always do with more scrap. Well, about 3 weeks ago, he eventually brought it round, and amongst it was some of this lovely brass bar, 20mm by 3mm. Came straight to mind that the obvious thing to make out of brass bar is magnet. Now, to make good magnets, you do actually need some non-ferrous metals. Be starting with two inner plates made out of the brass, and into those plates will be pressed two neodymium magnets. The other component will be the steel or ferrous poles that will slide over those magnets to form a kind of cake or sandwich of ferrous and non-ferrous metals. And then that can be followed up by two brass pins that will rivet the whole lot together. Going to need to have 2 squares of the brass and 3 squares of the steel. But brass is a strange material to cut. You can cut it. A lot of people say you need very sharp tools to cut it, and I don't think that you do. But unless you're using sharp tools, you have very, very little feel about what's going on. That blade, that's a used blade, is just gliding across with no feel whatsoever. You can see plenty of chips coming out of it, but no resistance. Very strange feeling to cut brass. Steel, on the other hand, is a lot tougher. You get a lot more resistance to it. You put a lot more pressure on the saws and cutters to get through it. With this end mill, I should be taking a smaller cut or putting some oil on there to lubricate it, keep it a bit cooler. But I want to try and see how far it can go before the end mill is completely ruined. I don't have experience of how far cutters can get before you need to throw them away. So that's too deep a cut, and I'm pushing it too hard, and that's why you're getting red hot chips flying off of it. But after that, it could still cut just as well as it could, which is not very well, but it didn't do it that much harm. But this is becoming my preferred way of removing larger amounts. Come down with the cutter and peck away at it. The teeth on the end of the cutter seem to be much more suited to removing rough amounts of material like this. Makes the machine judder around a lot. It's not a very stiff machine, but it's better than trying to face off on the side flutes. And then once most of the material is off, bring it down and face it off for a flat end. And that's approximately 20mm squares of brass and steel. Need to make the large holes in the middle of the brass, so I'm using a center drill, because you should do anyway. But the thing about the center drill, it has 0 rake on the flutes, and brass doesn't like a lot of rake on the flutes. It will tend to grab and try and feed itself through the hole. So with 0 rake, it is a lot more controllable. Now that's got a 4mm tip, which I'll need later on to drill 4mm holes, but it's 10mm outer diameter as well, so I'm taking it right the way through to remove most of that hole. And then to bring the hole out to 12mm, which is the size of the magnets I've bought, 12mm end mill. Now drilling holes for the brass pins. As I said, that's a 4mm tip on that drill, but I'll take it down just a little bit more than that, and that will countersink the hole slightly, remove the burrs, at least from one side. There's the packet of magnets bought from Amazon. You can choose which size you want. These are 12 by 3mm to suit the material. Press them in gently with a non-magnetic hammer. And then once they're put together in a stack, they will form a fairly strong square shaped magnet. But I wasn't sure what to do about the polarity of the magnets, so I have this magnetic field detection film. I knew I'd use it one day, and it shows you where the magnetic flux is concentrated. So with the magnets in that orientation, the flux seems to be concentrated only in the center plate, the center steel plate. So taking that stack apart again, and turning the magnets round so that I've actually got like for like poles facing each other in the center of the magnet. Now the flux is spread across the whole area of the magnet. Using the same center drill, making the 4mm holes in the steel plates, but in the end plates making sure I go down quite deeply to put a fairly generous countersink in the end holes. That will take up the riveting over of the brass pins when they're inserted. The length of these pins is quite critical. They need to be long enough so that they protrude out of the end of the stack, but not too long so that there's too much material to rivet over. This is kind of a moment of truth here for whether or not those pins are both going to go through. All of those holes have been drilled separately in a vice stop setup. You could stack them all together and just drill through the whole lot at the same time. They're guaranteed to be lined up then, but I'm pretty pleased with the way they went in. It means they were all drilled in the same place. Those two washers have been picked so that they are the right thickness, so that when I rivet over one end of a pin, it will leave enough material sticking out of the other end to rivet the opposite end as well. And if you ever wondered what a ball peen hammer is actually for, what the ball is for, that's it. That's its job. It's kind of a bit too much material sticking out there. It's too much to rivet down. And brass work hardens immediately on the first strike, and it's all starting to break up, leaving a bit too much sticking out, but that's going to be machined off anyway to make it flush. Now it's formed into a pretty solid stack, but none of the edges line up. They're all roughly dimensioned. So what I want to do now is make them into a fairly decent square shape of about 19mm. So I pretty much know what size they are. I choose 19mm because that's pretty much 3/4 of an inch. Easy number to remember. But machining a magnet is a horrible thing to do. None of the swarf goes anywhere. It just all sticks there like a big furry ball. It gives a pretty poor surface finish, as well as all the swarf gets caught up in the cutter. It never flies off and gets out of the way. This is setting up to machine off the end faces. The end faces are of no practical use, but they have that brass pin rivet sticking out of each end, and just want to smooth that down just for prickiness, really. Same problem with machining a magnet though, pretty poor rough finish. As a project and first attempt, that was fairly successful. It's pretty strong. It's just a bit rough looking. So the following day I decided I was going to make another two. I'm going to make them as a matched pair, and that allowed me to cut the material much more efficiently. So that's 2 pieces of steel bar there. That's going to create 6 steel plates in the end. It's a lot easier to machine multiple things at the same time. The second pair of magnets were a lot faster to make. But not without problems. That needed to be sticking out the vise like that so I could measure it, but I'm trying to machine off too much and it moves because there wasn't enough gripping it. So learned a lesson there not to bite off too much. Those 2 pieces are actually scrap. I had to make some more. And I moved over to a fly cutter to make the matched pair. So machine them both at once, they'll both be the same size, and the fly cutter gives a much better surface finish. That was the first one, and these are the matched pair. You use these magnets for setting up workpieces and clamping arrangements. Sometimes you can take measurements off them and things like that. They're very, very handy. Strangely, they're not too easy to buy though, but don't need to now. Made them.